I published, say, approximately 2 weeks ago a video about old schematics of the 1960s and the 1970s, and perhaps it's a good idea to pay more attention to all these old schematics because they are easy to make. Often there's one transistor or 2 or 3 transistors, so that's in general a very good idea. We live now in 2026 where, say, electronic circuits are quite complicated. I don't talk about computers, etc. My focus is always more or less on old school analog circuits that work, and that's very important that they work. Well, this is an old schematic also of the 1960s, I think, and it is a circuit of a relaxation oscillator. Well, we have here a neon tube. Parallel to that neon tube there is a capacitor, so we have a time-dependent circuit, and also here with this resistor. Problem is only that you need 90 volts to make that work, and you get a sawtooth like output. Anyway, I think on a high frequency, but of course it depends on the value of the resistor here and the value of the capacitor that bridges the neon tube. So let's go to the next one. What's this? Vibrato unit. Well, has everything to do with organs, etc. What's the function of a vibrato unit? Well, it acts on a very low frequency, say in the order of 2 Hz up to 10 Hz, and at the same time it drives a amplifier, so that you get a kind of wobbling audio output. These are, say, this is the schematic. Of course, all old school. There is here an indication that it is a AC 127. That is a germanium transistor. And that's okay because this is an NPN transistor here. And this is also an NPN transistor. This indication tells us that it is a BC107. You can use here a BC547. Sorry. Yes, a BC547. That is an NPN transistor here. And here also, instead of that AC127, also a BC547, and also here a BC547. Anyway, vibrato units. So, well, let's go to the next circuit. What's this? Sine to square wave. Well, that is in fact very simple. And well, this is, say, a good idea. Properly working circuit. Input here, of course, I don't know the frequency where this will work. Between perhaps 50 Hz up to 20 kilohertz. That is in general the frequency band where such a circuit works nice. And we see here at the output, say, the square wave, this square wave here, and we also see kind of needle pulse. And that needle pulse is generated, sorry for the movement, this needle pulse is generated by using this tiny capacitor of 1000 picofarad. and by using the diode and these two resistors. Anyway, let's go to the next schematic. My camera will run for approximately 15 minutes or so. Well, the Schmitt trigger circuit. There are a few videos about the Schmitt trigger on my YouTube channel. At least 4 of them where I've used it. The classical idea of the Schmitt trigger is that we have two emitters here of the transistors connected together. And here is, say, the load of the Schmitt trigger, and here we have the resistor. And you can also use such a circuit, Schmitt trigger, to drive a relay. And circuits are on my YouTube channel. And of course, when you want to drive a relay, you don't need here a resistor in the order of 56 kilo ohms or so. That is far too high. Say, here a relay and here a resistor in the order of 10 ohms up to, say, 50 ohms. And, well, also not explained here, and that's in a certain way typical problem. This first transistor here has to be set to a working point, say a bias, and that's not showed here. So I cannot advise to use this circuit, though it was in a good, reliable electronics magazine, etc. So what's this? Oh, we have no component values here, so I skip it. What's this? The simplest bias arrangement as possible. Well, when you know a little bit about electronics, this is, say, one of the most important circuits. You can use here a NPN transistor. This is a Germanium OC71. You can use here a BC547 base silicon transistor. Connect the emitter here to the ground. Use here a 1 kilo ohm resistor. And don't use here this resistor, but so skip this and connect here a resistor of 220 kilo ohm. And then you have the most basic transistor amplifier that you can make. And it's also the bias is also very okay. So of course, when you use here a silicon NPN transistor, this voltage must be positive up to 9 volts. So 9 volts here, that works best. I've tested this over and over many times, and when you go to my YouTube channel you can find these circuits. At here positive 9 volts, here 1 kilo ohm, this is skipped, and here we have the resistor of 220 kilo ohm going to the base. And it means that this transistor in that case that I mention here gives out its maximum current amplification. Say when you use here a BC547 and its current amplification is 300, you will have here an amplifier that amplifies 300 times. And of course, don't forget here, when you want to couple a signal in, don't forget here a capacitor in the order of 100 nanofarad, that is 0.1 microfarad. Oh well, this is I'm telling this all, but this is, say, the circuit that I mentioned, and here they use 6 to 8 kilo ohms. I use often 1 kilo ohm. So let's go to the next schematic. No indication of value, so skip it. This is also again about very old school germanium transistors. I don't want to dive too deep in this circuit. More or less obsolete, but on the other hand not obsolete. You can replace these two transistors, but it takes too much time to explain how to get it working. Anyway, thanks. What's this? Again, germanium transistors. Same issues. Let's skip it. Also here say, well, this is interesting of course, but anyway, you can try to make it. Here a PNP transistor, here an NPN transistor. I'm more or less sure that you can make this working as an amplifier. Use here a BC557 and here a BC547. NPN here, PNP here. Anyway, let's go further. What's this? Emitter follower made again with two PNP transistors. I skip it, thanks. Complementary arrangement of transistors. I also skip this. What's this? Active low pass filter. Well, this is, I think, very interesting. You can use here a PNP transistor, say a BC557, and here we have a resistor and another resistor, and here my idea is to get this working. Use here for instance a 1 kilo ohm resistor. Use here for instance for a first experiment 10 kilo ohm, 10 kilo ohm here for a first experiment, 50 nanofarad here, and here say 0.1 microfarad, and here a 1K here and 220 ohms here. And when you bridge this 220 ohms resistor with a capacitor of 50 nanofarad, this can work. Of course, this will say work in a certain frequency band. Anyway, no values here, but say what I've told are say kind of first ideas to make this working on a certain frequency. And of course this resistor and this, they all work as a kind of filter, specific filter. Anyway, well, here is the response curve for that ID. And of course I did not show I only showed some IDs, so it means that that response curve, well, anyway. A low pass filter. You can use here a PNP transistor, the BC557. You can positive voltage, of course, here. Reverse the cap here. Well, I think this can work nice, but I don't know how the bias of this filter transistor is set. So perhaps you need here a separate bias potentiometer in the order of 22 kilo ohm with a protective resistor to the negative or the positive lead. Want to refer to my earlier video. Anyway, high pass active filter. Good idea, Problem is that no components are showed. High pass and low pass filter. Well, here are the component values are showed. You can use here a BC557, also here a BC557. This is minus 12 volt. When you use a BC547, it's NPN, and also here BC547 is NPN. This must be positive 12 volt. This capacitor must be reversed to the output. A high pass filter. What's this? A phase shift circuit. Well, I skip it. High to low impedance unity gain converter circuit. Well, this is interesting. Positive voltage here. Use here a BC547. Use here a BC557. This is PNP and this is NPN. I think it will work. My camera will stop suddenly. Anyways, thanks for watching. A complete practical circuit for a pickup preamplifier. Well, that's another, say, a chimes unit. Well, there is a chimes unit on my YouTube channel, and I will give the link. What's this? Two-wire, two-way intercom. Well, interesting. Of course, you can use this circuit, but in general, you can use any circuit of an amplifier. For instance, with a chip amplifier in the order of 1 watt or 0.5 watt. And of course, you have to find out, say, the listen and talk switches. Anyway, what's this? Wien bridge oscillator. Well, that's really a pure principle sine wave oscillator. Well, very interesting. I've tested it and it worked. By the way, use here a potentiometer of 22 kilo ohm and connect the top of the potmeter with a 1K resistor to the positive lead, the wiper to the base, and here this part of the potmeter to ground, and set the bias so that the whole circuit oscillates. These are, say, more or less standard values, but they often don't work. That's the problem. With a potentiometer you can set the bias and you can set the oscillation, and there are many videos on my YouTube channel where that is explained. So, what's this? Don't know that. Anyway, what's this? All kinds of oscillator circuits. Well, are there component values? Yes, they are there. You can make such a circuit in a very easy